Yes, you are first to join this live class, Sarita. Good. Um, I'm just waiting for it to be 7 o'clock. I hope my voice is audible. Yes, my voice should be audible. Hmm. My streaming? Yes, I am streaming. And I'm just checking if everything is right from my side. So, so cool. Seems like I have everything here. Just checking if my sorry. Just checking if my audio is clear. Is my audio echoing? Okay, so I see what's happening here. I think I'll have to. Yes, can you guys hear me now? My audio should be clear, but open threshold after. I think we can work with this. Or if I completely remove this filter, I think this can work. Okay, so welcome everyone. I'm just going to stay here and start the class today. Cool. So Sarita is asking, what are we going to do today? We are going to be making a Subway Surfer game. So you guys must have played this game called Subway Surfer in camera is there. I'm so sorry. Okay. Yeah. What I'm saying is, like a few years back, there's this game called Subway Surfer that came out on App Store, and you guys must have played that, or it's still available, I think. So you guys can play that as well. So what we are going to do today is we are going to be making a same game, a copy of the game on Hatch, a 3D a VR version of the game. So I'm going to show you what we're going to do, and this game can be built on both Hatch XR with JavaScript coding. So we have two platforms. We have Hatch XR with JavaScript coding, and we have Hatch for Kids with block coding. So what I'm going to show is we can make the game both in JavaScript with JavaScript code and with blocks. So let me just run this code here, this project here. So the completed project of both of these project links are available in this video's description. If you check on the YouTube's video description, I have added both the links of the completed project for JavaScript code and the blocks code in the video description. You guys can open that and check the game for yourself as well. So I'm just going to run this game and I'm going to show you how this works. So I'm running the blocks based version right now. You have 1 second, my camera turned off. I'm just going to turn it on once. Let me just check if the focus is correct. Yeah. Sorry. So sorry about the camera thing. Okay. So I think it's still out of focus. Give me 1 second. I'm just going to focus it. Actually, I'm just doing this whole thing by myself, so I am. It's going to be a weird frame for a few things. Okay, I'm just using my hand as a reference. I think, yeah, this should be working fine. Okay, cool. So what I am going to show here, okay, yeah, so what I'm showing here is the Subway Surfer's block-based version of the code. Okay, so you can see my character is running, and there are obstacles coming on the left, right, and the center, and so I can collect the coins, I can jump and I can collect the coins, I can, oops, yes, so I can roll under the obstacles and I can walk up the obstacles. Yep. And let me just show the JavaScript version of this. This will run a bit faster. So what happens is, yeah, so I have my player and I can make it move left or move right, and see I'm collecting coins, and as I'm collecting coins my score is increasing. Then I can move to the center and collect the coins, jump over the obstacles and jump over the ramps and collect these coins, and then the obstacles are appearing randomly on the left, right, and center with more and more coins. So yeah, just a copy of, not a copy exactly, but yeah, not a copy, a version of Subway Surfer on JavaScript with HatchXR. So I'm going to be showing you how to code this in JavaScript with the HatchXR platform. You guys can use, you guys have both the completed projects of JavaScript code and the block-based code. So you guys can refer to both of those. And if you guys want to learn the block-based code, I can do a session for that some other time as well. So today we are going to be doing the JavaScript version of this. So let's begin. So we are going to just open up hatchxr.com. I'm going to close this project that we have here. So yeah, I'm going to open this up and just ensuring I have everything running here properly, and cool. So I'm going to open up a new project. I'm going to open up a new project. It asks me an unpublished project was found. Do you want to reload that project? I'm going to click on no for this. So this message will appear only if you have used HatchXR before and you close HatchXR without saving the project that you were working on earlier. Okay, so in that way we save your previously unsaved projects if you close your browser by mistake. All right, yeah, so as you can see, let me just full screen this window. Yeah, so I have my HatchXR screen here. This is the default scene that we have, and we are going to start building our HatchXR game, our Subway Surfer game. So how are we going to do that? So the first thing is, what do we need? First thing we need is a character, right? A character that is running around. So you'll see in our 3D model section here, we provide an option of player avatars, and we do have animated characters here, but these characters have running, walking, jumping animations. Remember, I showed you in the game right now, my Subway Surfer game, the character was rolling as well. So these characters do not have a rolling animation. So what I'm going to do is, I have added a rolling animation on a character in Sketchfab. So I'm just going to search for my character. So it's an animated character. So I'm just going to select the checkbox of animated here. And I know that I have named it Hatch. So I have named this character, lead character, rigged hatch. So I'm going to add this character here. So you see, I'm just going to click on the plus sign. It says loading, and see, my character is added. And now if I double click on the name of the character, I will go close to this 3D model. So you see, I have this 3D model here. And if you notice its properties, so this properties of my 3D object, here it has a built-in animation. And you can see I have added certain animations that I want to use. So fall, jump left, jump right, jump up, move left, move right, roll, run and walk. So I'm going to use these animations of my animated character. All right, so how are we going to code this game? So first of all, let me go back, let me reset my camera's position to the center. So I'm here, so I want my character to be with the player. So I have a player object here, I want my character to be inside the player. So what I'm going to do is I'm going to just drag the character from here and place it inside the player object and then make its position 0, 0, 0. So my character now comes to a position that is the same as the player. Okay. Now you can see my camera is just above my character. So I'm going to click on the camera and I'm going to move it behind. So you see my Z value is increasing as I move the camera behind. So let me just add a value of 5 here by myself. Okay. So now my character is below the ground. Let me increase its Y position. So Y position 1, and I have to, so see right now my character is facing the camera. It needs to be facing the other side. Yeah. So I'm just going to rotate it in the Y direction by 180. So now my character is facing in the opposite direction. Now let me just delete this box, sphere and cylinder. So box, sphere, cylinder, all of those. I'm just pressing the delete button on my keyboard and that selected object gets deleted. Okay. So now I have the scene here. So if I go to the code window, you will see that my character here is just standing like this. Yeah. So it needs to have some walking animation. Okay. So I'm going to go to the design tab again, and here I'm going to select my character. First of all, see it has a very big name. So I'm going to rename it and just name it character for now. Okay. So by default, it needs to have a running animation. So I'm just going to say, select the default clip. So in the built-in animation properties of animated objects, it has this clip property. So here you can select the default animation that will be running on this object all the time. So if none of these animations are coded, as in if I don't code my character to do any of these animations, then by default my character is going to be running. Okay, so that's done here. So now if I go to the code window, you will see here by default my character is running. Okay, now there is one problem. So if you will see here, my camera, I just need it to be positioned a bit higher, and notice I'm just going to show you a few things that we can make really interesting in the game. So you will see if I move my player, right now I am just able to move it front, back, left, right. Yeah, I'm pressing the space key but it's not jumping. So how can I make the player interact with the environment? So if I click on the player, you will see player motion has certain properties here. So there is a property called collide with surfaces. So if I select that, now if you see, if I go to the code window and if I click on the front, back, and you see if I press the left and right, my character is turning around, and with front and back it's running, it's moving front, back, and if I press the space key, it's jumping. Okay, so remember some of my obstacles had a ramp. So my character right now, my player will not move up the ramp. To make it move up the ramp, there is a property here in player called hill climbing. If you enable this, now I'll show you. Let me add a box to my scene at 0, 0, 0 and move it behind -10 units. I'm just going to rotate it by 45 degrees. And I'm going to increase its size. Yep. So see, there is a ramp in front of my player right now. And if I go to my player here, and if I deselect hill climbing, if I disable hill climbing, and I go to my code here, and I try to move towards this object, see, my player just stops in front of the object. It's not walking up the ramp. To make it walk up the ramp, we have this property of hill climbing. So if you go to player and if you select hill climbing right now, go to the code window, and now you see my player, and if I see so the box had two ramps, one up and one down, so it walked towards that. So see, this is the down ramp. Yeah. Okay, so this is done. Now, once again, my camera turned off again. Just going to see if my has, yeah, it has proper focus. Cool. So now let's go to the design mode, and I'm just going to show you guys. Let's modify the scene here. Okay, so we don't want when the player, so in the Subway Surfer game that you guys actually play in phone, it looks like the player is running forward, but what happens is the player is not running forward. It's the ground and the obstacles and all the coins that's moving towards my player. My player is just standing at one position. So we are going to code that now. We are going to start coding with that. So how do we do that? First of all, what you have to do here is, if you go to player, we want our player to walk up the hill and we want our player to jump up and down. So we need the collide with surface property. But we don't want our player to move forward and backward when we press the forward and backward arrow keys. So to stop that, you see there is a speed property here. This defines the speed with which my player will move forward or move backward. So if I make it 0, then my speed is 0. So now, even if I'm pressing the forward or backward arrow key, my player will not move forward or backward. See, now I'm trying to press my up and down arrow keys, but my player is not moving forward backward. But if I press a jump arrow key, jump button, space key, my player is jumping up and down. So we needed the jump and the ramp hill climbing property. That is why we have selected the collide with surface. And also for the left and right arrow key, remember in our game, the game that I showed you, my player was moving to the left and right side. So here you will see that left and right action, it is set to rotate. We want our player to move sideways, not look left or right, but move to the left or right. So that is why we are selecting the move sideways properties. Okay, so now we are done with the design thing here. Let's just modify our ground. So I select my ground property, ground object here. I'm going to make no grid, and texture I'm going to make checkerboard with a darker color. Okay, yeah. So now what I'm going to do is I'm going to reduce the size of my ground a bit, but I'm going to make it thinner. So I'm going to reduce the X scale of my ground to 0.25. Yeah, so you see 0.27. So I know what value I want here. That is why, because I've made this game beforehand, so I know the values that will make the game look nice. Otherwise you can just try and see by changing the scale manually which value looks good. So I know that when it's 0.27, my player has enough space to move left once and move right once, and then the obstacles will have enough space on the left and right side. Okay, so yeah, cool. Now I have this ground here. Okay, so now let's code the motion of the ground to make it look like the ground is moving towards us. Okay, so I am in the code window. Let me zoom this up a bit. Okay, so what we want is, we want our ground to be moving towards us. So by default, whenever I'm coding any game, what I do is I create two functions. One is a setup function, and one is a loop function. So there are lots of things in my game that runs continuously. So that runs in the game loop function again and again. And in the setup function, we define, so everything, all the properties of my game when it needs to start, that is what I define in the setup function. That is what I will define in the setup function. So basically the setup function is going to be called at the starting of my game, and it is going to whatever properties we're going to set here, we will set here, and then we are going to run so I'm just going to create a variable called loop. Okay, and I'm going to say loop is equal to, so window.request animation frame is how I'm going to run this game loop again and again. Okay, so request animation frame, and inside the round brackets I write the name of the function game loop. Okay, I think it's becoming a bit larger to see. Yeah, so first of all, see, I'm just, so let's say I want when I want my what I'm saying is, in the setup function, so when a game starts, we want there to be no obstacles, we want the score to be 0, we want the ground and everything to come back to its initial position. Okay, so like when you code game over and then a restart button in your game, so when you click on restart, basically your setup function has to run again, right? So setup function, in the setup function you define all the initial properties of the game, and after the properties are set, then you call this game loop function again and again. So to do that, you call the game loop function here once, and then at the end of this game loop function here again. So this then runs my game loop recursively again and again. So now what we are going to do is we want our ground to be moving towards us, right? So we are just going to first of all define a speed for our ground. So I'm going to create a variable called zSpeed, and I'm going to give it a value of 0.2. Okay, so now what I'm going to do is I'm going to say that my ground object, ground dot set x to ground dot get x, find its current x position and add the zSpeed value to it again. So now you see, if I just run this function, run this code, my ground is going to be moving, x. I made a mistake. So x is the left and right direction in our scene by default. Z is the front and back direction. I want my ground to be moving towards us. So set Z and get Z value. My mistake. And let's run this. So now, yeah, see, my ground is moving towards and then my ground left. Yep. So let me show you what we want to do. I'm just going to see if I have a whiteboard here. So Microsoft has a whiteboard. I'm just going to use that to show you guys what I want to do. And then, okay, so what I'm going to do is, I need a new whiteboard. Okay, yeah. So see, what we want is we have a ground. I'm looking from the top. Okay, imagine me looking from the top. So this is my ground, and it is moving in this direction. My player is here. So when my ground, one second, sorry. My frames are not dropping, but why is this? Okay, cool. I think is my video lagging, guys? One second. Okay, so I don't think my video will be lagging anymore. All right. So yeah, my player is here, and this is my ground. Okay, so my ground is moving in this direction, and see, when this edge moves, when my ground comes like this, after that my player is standing here and the ground has moved away. We don't ever want our ground to move away, right? So what we are going to do is we are going to first of all add another ground here. Okay, so when this ground and both of the grounds are going to be moving together. Okay, So when this edge of my ground appears here, visually it will look like the ground, like it's just one piece of ground that's still moving. But now what we are going to do is, we can, after this ground has moved behind the player, we can move the position of this ground here. And then this ground can move this way again while this is moving here. And when this edge reaches my player, then wow, I did not know. Okay, it looks like, sorry, that's a new camera. It has a setting of 20, it should have a setting of 30 minutes. I have not changed that to 30 minutes. It's by default set to 10 minutes. That's why it's happening. Okay, I'm so sorry about that. Cool. So let's come back here. So what I was saying was, we are going to be moving, basically we are going to be moving the ground in a loop. So there's going to be these two grounds. Okay, and when this edge reaches my player here, we are going to move this ground behind my behind the second ground, and then both of these are going to continuously move towards my player. And when this edge becomes like this, then again this is going to move behind my ground. Yep. So we just need the position values. Let me code and you'll understand what's happening. So first of all, I'll go to the design tab and I duplicate my ground. Okay, ground 2. So right now this ground has a width of 52 meters. So I have to set this ground 2 at -52. And see, my second ground has moved behind my first ground. But because they are joined, they have the same texture, they have the same pattern, wherever they are joining, it looks like it's just one piece of ground, right? So now if I code and I just write here, move ground 2 dot set z to ground 2 dot get z plus z speed. Now see what happens. Both of my grounds are moving towards me, right? But now what we can do is, we can add an if statement. If ground 2, if ground dot get z, if the z position of my ground is greater than, so 52 pixels, 52 meters, my original ground is at 0, my second ground is at -52. When the first ground reaches z position of 52 greater than equal to 52, what we are going to do is we are going to set ground dot set z to -52, and we are going to do the same thing for ground 2 as well. There is an easier way to do all of this. I'll show you just after this, just after writing this code. If ground 2 dot get z, then ground 2 also. So now see, it's going to look like my grounds are, see, you saw another ground appeared here. Yeah, you see the grounds keep appearing here because you see what's happening. My grounds from here, the moment it reaches behind me, it disappears and then it appears in front of me. Okay, so now it looks like there is an infinite ground on which my player is running. With just two pieces of this ground block, we are able to make it look like there is an infinite ground on which my player is running. Okay, so now let's do something here. Let's write it in a better way. Okay, this is not a good way to write the code. So first of all, what I'm going to do is I'm going to create an array. I'm going to create an array, and I am also going to So rather than just using two grounds, I'm just for myself, I'm just for things to look not that abrupt, I want my newer ground to appear further away, so I'm going to use 3 ground blocks. It's just my for a convenience. So all of these are 52 meters in length, so I'm just going to move it another 52 meters behind. So that is minus 104. So now I have 3 ground pieces, and I'm going to go to code, and what I'm going to do is I'm going to create a variable here called gr, okay, and make it an array of what? Of ground, ground 2 and ground 3, okay. And I'm not going to do this thing here. I'm just going to create a function called move ground. Every activity in your game, you can define them to be new functions. It's much more easier because moving the ground, and I'm going to call this move ground function inside my game loop function again and again. So now inside my move ground, what is supposed to happen? We are going to go through each element of the gr loop. So let g of gr, that is a way to iterate through all the elements of an array. So g is going to be first be ground, and then it will be ground 2, and then it will be ground 3. G's value will change in every iteration of this for loop. Okay, so let g of gr, or I'm just going to do it in a better way. I'm just going to call it grounds, and let naming should be so grounds, let g of grounds, and what we are going to do is we are going to g dot set z to g dot get z. So g is going to be ground, ground 2, ground 3. For all of them, whenever it so for all of them, they set their z value to their current z value plus the z speed value. Okay, and then what we are going to do is we are going to check if the g's or g dot get z is greater than or equal to 52. If it is, then g dot set z will be minus 104. Now the final z position of the last ground is minus 104. So that's where we are going to be positioning all of my grounds whenever it's moving back. Okay, and this should be doing the same activity that it was doing earlier, just in a more efficient, more cleaner way. The code is cleaner. So see, now earlier you were able to tell when the ground was appearing. Yeah, we don't want, whenever somebody is playing our game, we don't want that to happen. We want the kids, we want our users to Gagandeep is saying that he's not able to access HatchXR. Gagandeep, the link of this project is in the description. Try opening that. You will be able to open this up. The workspace does not open up on mobile. The workspace can only be opened up on laptops or desktops. Okay. What you need is on your phone you will only be able to play the games. Okay. So yeah, what I was saying was when I was running this function now, you would have noticed that earlier when I just had 2 grounds, I was able to tell when the ground was moving, like when the ground was appearing suddenly in the background. Yeah, we don't want our users to be able to know that. So further away, you will not be able to distinguish when the ground is appearing in the background, because just by adding an extra ground. So it's just the code that you write, let users not feel that there are disruptions in the code. Okay, cool. So I have ground thing is done. Let's work on obstacles. So what we are going to do is we are going to make 3 obstacles, 3 types of obstacles. Okay, so I'm going to add a box first of all, and I'm going to position the box at 0, 0, 0. Let's position the box here a bit. Let's move closer to the box. Yes. So what we have now is we have this box here, and I want this box to work as one of our obstacles. So let's modify the properties of this box. So first of all, so I know that my ground is right now 14 meters wide. So what I can do is to modify the design of my game. I'm adding another box here, and I'm going to move it to 0, 0, 0. So basically my plan is there are 3 lanes on this road. Yeah, my player can walk at the center, my player can walk on the left side and on the right side. So I want each of those individual sections to be 4 meters, 4 meters, 4 meters wide. So that makes my entire road on which my player can move to be 12 meters wide. And then I want 1 meter gap on the left and right side. So that is why my one second, sorry. Yeah. So because yeah, what I was saying is, let me see if the camera thing is fine. Okay. Yeah. So 4 meters, 4 meters, 4 meters, and then I want 1 meter gap on both the ends. So that is why my ground is 14 meters wide. Okay. So I want each of these obstacles to then basically be, not cover the entire 4 meter wide width of the road. So I want the squares to be a bit smaller than that. So I want the width of my obstacles to be 3 meters. And so if its width is 3 meters, then height also be 3 meters. And let's make the obstacle longer. So when you see in your Subway Surfer game, you have train coaches, right? And they are longer coaches. So let's make it like 12 meters wide, 12 meters in depth. Okay, so this can work as an obstacle. Now you see right now my scene is too dark. Let's add a light first of all. I'm going to add an ambient light that brightens up everything. And I'm going to reduce the intensity of my ambient light so that it does not brighten up everything. Everything is not too bright, okay? So now I have this first box here. Let's modify its other properties. So first of all, there is a roughness property. I want it to look rough. I did not want it to be reflecting a lot of light. So I'm making its roughness 1. And then let's make its color a bit on the white side. Yep. Cool. So if this is 3 meters in height, its Y position will be 1.5, and then it will be touching the ground. Like it will be completely touching the ground. Okay. So I have this obstacle here. Now, what I was doing with the second box here is I was going to add the second box at Y 0.5, Z 0, and X to be 6.5. So so remember I told you my roads are going to be 4 meter, 4 meter, 4 meter wide, left, center, and right, and then 1 meter gap on both ends. So those 1 meter gaps, I'm just going to add this like a rail. Okay, just a design thing, not don't think too much into it. It's just the way I want my game to look like. So I'm just going to give my box the correct the color of the ground. So I went to my ground properties and selected the color from here, and I copied the color, and on this box I'm just going to add the color here, and I'm going to make this box very large, 104. Yes, and I'm going to copy this box, and I'm going to make it move it to the left side as well. So now you see when my player moves on the road, it just looks like there are barricades on the edges. It doesn't fall off, just for that, just to look good. That's why I've added these boxes on the left and right side. Ignore it if you guys. Okay, my camera's battery is dying. Wow. If you guys hold for 2 minutes, I'm just going to reset the battery of my camera. Okay, I think it should be fine now. Okay, focus is the only issue. Let me just focus. So focus, it has to be here. Yeah. Cool. Battery is replaced, and now I have full thing here. Okay, so let's move back to my game. Now, yeah. So now, as I was saying, let's make different types of obstacles. So I have this one box here. Okay, I'm just going to, reduce the intensity of this ambient light. Okay, so I have this one obstacle here. I'm going to rename it as obstacle. Okay, and I'm going to clone this, and I'm going to clone this again. So when I clone this, let's make it move to the x position -4. So obstacles are going to be positioned in the x position 0, means center, because each road is 4 meters wide on the left and right side. So the x position of my obstacles can be 0 or +4 or -4. See, that is why I was just talking about dimensions for this long here, that I've made the road 14 meters, 4, 4, 4, and then 1 meter on the left side and right side, so that my obstacles will fit properly. So now different types of obstacles, right? So obstacle 2, let's make its depth to be 0.5 and its width to be its width to be 3, but height to be 0.5, and I want it at 2 meters. So I want a barricade under which my player can roll. Okay, so to do that, what we are going to do is we are going to so to do that, what we're going to do is we are going to add 2 more boxes here on the left and right side. So I'm going to make those boxes a child of my obstacle 2 and make their height 2, their y position to be 1, sorry, y position to be, y position to be, so this has a y position of 2, the y position of -1 from it, and a width of 0.5. So these are values that I know. I'm just calculating them based on dimensions, because I know the y position, x, y, z positions of my boxes are defined at the center of my box. So if my box is 2 meter in height, it's for it to be just touching the ground, it needs to be the y position of the box needs to be 1 meter above the ground. Okay, but because my obstacle is already 2 meters above the ground, and this thing is a child of my main obstacle, so if it's 2 meters above the ground, from that 2 meters it needs to be 1 meter below the ground to just look like it's on the ground. I'm sorry if I'm confusing you. I'm just going to show you guys easily. 1.25 will work here, and then obstacle 4 will have -1.25 -1, same values, just width. You guys can copy paste these values for now. Yes, so this is a second type of obstacle for me, under which my character can roll. Okay, and third type of obstacle will be a ramp. So I have this box here. What I can do is I can clone another box out of it, make its height, width, and depth 3, 3, and 3, basically like a cube, move it in front of my original box, and then rotate it by 45 degrees. So now So, but you see the ramp fits, but it does not like fit from edge to edge. So what can we do? I'm just going to increase its width and increase its height and depth. 4.3, 4.3. There is a reason I'm using 4.3 is because if your cube has a dimension of 3, then it has a diagonal of 3 times root 2, yeah, square, and this line has to be equal to the diagonal's length. So that is why 3 times root 2 is 4.3 approximately. And now if I move it just to the ground, it will fit properly. See? So this is my third obstacle. Okay. So obstacle 2, obstacle 1, obstacle 3. Now what are we going to do? So the way we were moving the ground, similarly, now we are not going to be moving just these 3 obstacles. What we are going to do is we are going to clone obstacles and then move them continuously. So what we were doing for ground was we are moving these 3 because we don't want a lot of grounds to be created again and again. We can just use these 3 grounds and cycle them, right? Once this ground moves far behind, it can go back and then again start moving from behind and come up again and then go back and then come up again. So all the ground fragments are cycling. But for obstacles, we can't cycle them. What we will have to do, because we want obstacles to be randomly placed and randomly generated. So what we are going to do is we are going to first of all move these obstacles far behind. We don't want these obstacles to be visible directly. So what we are going to do is, so we have 3 lanes, lane 1, lane 2, lane 3. The left section of my road, the center of the road, the right section of the road. So what we are going to do is, we are going to first of all, let's go to the code window, okay? And I'll show you. So whenever we are creating an obstacle, so first of all, we need to decide, do we want an obstacle on the left, center or right side? So what I'm going to do is I'm going to create a variable called should we add an obstacle? So add obstacle. No, let's call it, is there going to be an we're going to check, is there going to be an obstacle on the left, center and right side? So I'm just going to create a variable called isObstacle, and this is also an array because left, center and right. So we are going to create 3 obstacles at the same time, one on the left, one on the right, one on the center. So here we are going to add 3 elements. Now these I'm making it false, false, false. Now JavaScript has this Boolean variable called true or false. Okay. So what we're going to do is we are going to randomly change these false, false and false to randomly at any point of time. Whenever we are creating an obstacle, we are going to change the false to true. So my isObstacle array can sometimes be true, 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 can sometimes be false, true, false, false, true, true, can be any combination of true and false. We will be coding that, okay? So then whenever we are generating obstacle, what we are going to do is we're going to check if the first element of this array is false, then we are not going to create an obstacle on the left side. If it's true, only then we are going to create an obstacle on the left side. And same goes for center and same goes for right. If the second element of this array is true, only then we will generate an obstacle on the center. Otherwise, we will not generate an obstacle on the center. Okay. So this is the basic logic behind how I am going to generate obstacles randomly on the left, right and center. And then, so we have 3 obstacles to choose from. So first of all, we will decide, do we need to add an obstacle on the left or right, on the left side, depending on the first, second or third value of the isObstacle array. And then if this is true, then we will randomly select from obstacle, obstacle 2 or obstacle 3 and clone one of them in its place. Alright, so I'm going to create another array called obstacles. Obstacles, and so we have the name of my obstacles are obstacle, obstacle 2 and obstacle 3. So my camera is going to shut down every 10 minutes. Just have patience. I'm really sorry about that happening. Okay, so let's continue. So the name of my obstacle, the original obstacle objects are obstacle, obstacle 2 and obstacle 3. You can see on my screen here. Okay, here I'm guessing my head is hiding these. So obstacle, obstacle 2, obstacle 3. Okay, cool. So wait, it's here? Yeah, it should be here on this side, right? Not the character is running here from the way I'm seeing it. Yeah, the character is running here. Names are on this side, and the code is just here, I'm guessing. Okay, cool. So obstacle, obstacle 2, obstacle 3. So let's add those in an array. Obstacle, obstacle 2, obstacle 3. Okay. So now what we're going to do is we're going to create a function called generate obstacle. Generate OBS. Okay. So we are going to, first of all, I told you we are going to whenever we are generating obstacle, we are going to randomly change the value of this is obstacle array. So how are we going to do that? We are going to use a function in JavaScript that's called math.random. So math.random, what it does is it generates a random number between 0 and 1. Okay, and it's a pseudo random function. It generates a random number. Just assume that. Know that math.random is going to generate a random. It can be anything. So we're going to use that, and because it's a random number, we can generating any number between 0 and 1 is an equally likely possibility. So if math.random is, let's say, less than 0.5, so there is a half. So 0.5 is the midpoint between 0 and 1, right? Math.random can generate any number between 0 and 1. It can generate 0.1, 0.12, 0.234, 0.45678, something, 0.61, any number. Okay. So there will be half will be the possibility of generating a random number less than 0.5, and half will be the possibility of generating a random number greater than 0.5. So I'm saying if math.random is less than 0.5, then, and I think I'll for let IO of is obstacle. So I'm going to do this for each element in the is obstacle array. Okay, so we are going to loop through each element in the obstacle array, is obstacle array, and then our first activity is going to randomly change the value of that element. So if math.random is less than 0.5, I think I will need, so I can then say IO is equal to true. Otherwise, else IO is equal to false. Okay, so loop through each element of this is obstacle array, and then do what? And then turn them to true or false by generating a random number and checking if it's less than 0.5 or greater than 0.5. Okay, now if it's true, then what we are going to do is we are going to clone an object. So we are going to use this clone object function, okay, and we are going to clone one of my obstacles here. Which obstacle? So let me just delete this first of all. So we are going to first of all now decide if it's true, then we will create an obstacle on the left, right, or center. But now which obstacle to create, because we have 3 obstacles to choose from. So again we will use our math.random function inside this. So what I'm going to say is I'm going to create a variable, just variable r for random, just a variable, okay, and I'm going to say r is equal to math.random. So if IO is true, then generate another random number and set its value inside r. I'm going to say if math.random, if r is less than 0.3, so 1/3, 1/3, 1/3 chances of cloning obstacle, obstacle 2 or obstacle 3. So that is why if r is less than 0.3, then okay, going to create another variable called CO, just to keep track of which object to clone. So CO is equal to 0. So my array has 3 elements. The index of obstacle is 0, the index of obstacle 2 is 1, and index of obstacle 3 is 2. So CO can keep track of that. If r is less than 0.33, then CO is equal to 0. Else if r is less than equal to is less than 0.67, then CO is equal to 1. I'm just going to, yeah, and else, so either r is going to be less than 0.33 or r is going to be between 0.33 and 0.67, or it's going to be greater than 67. So I can just say else CO is equal to 2. So now that the value of CO is decided, I can then say clone object, hash.clone object. Which object to clone? I can say, I can refer my obstacles array, obstacles array, and square brackets, and write the index of which obstacle to clone. So CO. Okay, so I told you CO is 0, 1 or 2 randomly. Now that is going to decide that this obstacle is getting cloned. Okay, so let me show you how this works. Okay, so what I'm going to do is I'm going to generate obstacles whenever I click on my scene. Okay, so I'm going to say generate OBS here. But when these objects are cloned, where are they going to be placed? So remember, yeah. So clone object dot set z, we want them to be placed, we want them to appear far away and then come closer to us. So set z will be what? Set z minus 40. Minus 40 is far away enough. Yeah. And set x. So we don't have to set the y position. If we don't set x, y, or z, then the cloned objects will be, then the objects that we are cloning using code are going to appear in the same position as the original object. So see, I have my original objects placed behind me. So if I don't set x, y, z of my cloned object, I just tell hash to clone an object, then it will create the clone of the object, but it will clone them in the exact position of the original object. We don't want that. That is why we are setting the position. So we are saying set the z position minus 40. Now I told you we are not going to set the y position because all of these objects are already on the ground. So if we don't set the y position, then it will take the y position of the original object. So it will look like all the obstacles are on the ground. Okay, so we don't have to write an extra line of code there. Let's set the x position. Now x position is going to be what? X position is going to be, so I'll have to rewrite this let io of is obstacle in another way. So I'll have to say let I is equal to 0, I less than is obstacle dot length, and I plus plus. So I is going to start from 0, okay, and again, so I'm guessing, what time is it right now? It's 8 o'clock. Okay, so let's do the obstacle thing, and then we can end the session there, and we can do the coins and score and game end game restart thing in a part 2 of the video. Okay, so we are just going to do the, it's 8 p.m. it's not 9 p.m. Sam, I mean in India. I am in India right now, so if you are yeah, cool. Okay, so what I was saying was, so earlier I was there are lots of ways in which you can iterate through an element in an array, all the elements in an array. So when I was doing let io of is obstacle, so the way that works is io is a temporary variable that is going to be assigned to each element of my is obstacle array one by one. All right, but that way, so I'm not able to find out the index of io that I need here. So what I need is if the index of io is 0, that means this obstacle has to be cloned on the left side, so the x position will be -4. If the io's index is 1, it means center, because then the center element is true or false. Then the obstacle's x position is going to be 0. And if io's index is 2, that means I'm changing this third element's false to true or true to false. So then the obstacle that is going to be created on the right side, and its x position needs to be 4. So I need to know the index of io. Now there is another JavaScript function called getIndexOf. You can use that. I don't want to, so easier way to do this is I'm just going to do a normal for loop with a temporary variable I that is going to get values from 0 to, so io is obstacle.length is 3. Okay, is obstacle.length will find out the length of an array. So is obstacle is an array having 3 elements, so the length of my obstacle is 3. So basically I is going to be 0, then 1, then 2, and then when it becomes 3, then 3 is less than 3, that's false, so for loop will stop. Okay, so now I can say yeah, I don't need io's this thing here anymore. Yeah, so what I'm saying is I don't need io here. I can just say is obstacle and then brackets में I. So that's how I can now refer to the ith element of is obstacle array. Okay, and same goes here. Is obstacle brackets में I. So now I can say, now I know which index I am on. I am on 0, 1 or 2. 0 means left, 1 means center, 2 means right. So I can say clone object dot set x to, see, 0 means -4 is the x position, 1 means 0 is the x position, and 2 means 4 is the x position. I can write a formula for that. I can just say 0 means -4, right? So I times 4 minus 4. 4 times I minus 4. So yeah, this is going to work. So see, when I is 0, 4 times I is 0. So the x position of my cloned object is minus 4. If I is 1, 4 times I is 4. So 4 minus 4 is 0. So when I is 1, the cloned object's x position will be 0. And when I is 2, then on the right side. So x position of my cloned object needs to be on the right side. That means x value should be 4. So x value should be 4. So 4 times 2, that's 8, minus 4 is 4. Okay, so this will work. Alright, so let's see if this works or not. So I have written a code here that on scene click generate obstacles. So let's see. I'm going to click on the scene and see, when I click on the scene, 2 obstacles got generated and center was empty. Let's run this again and clone again. Click on the scene again. Now see, I got 3 obstacles, but center one is a ramp. Let's see if I can generate more random obstacles. See, now I have, when I clicked on the scene, on the left there is a ramp, on the center there is a barricade, on the right there is a ramp. So every time I click on the scene, there is going to be a different set of obstacles. So now I only have this left side. I don't have any obstacle on the right or center. Okay, cool. So we are able to generate obstacles. Now let's move them. And you know, when obstacles have gone behind me, we don't need any of those obstacles, so we can delete those obstacles. So we will learn these 2 things and then I will end the session for today. So what we are going to do is, first of all, we need an array where we can store all of these created obstacles. So I'm going to create a variable called barricades. That is empty. That is an empty array. So every time I create an obstacle, so I can delete this scene click thing. So every time I clone an obstacle, I can say, I can add that in my barricades array. So barricades dot push, and push what? Push the cloned object that we just created. Okay. So this is going to add all of the cloned obstacles in my barricades array. Okay. So now what we can do is we can write another function called move obstacles. Just like we created move ground as a function, I can say move obstacle, and I can say what? I can say if the obstacle, yes. So this is my, if the barricades array is not empty. So if the barricades array is not empty, I can just say if barricades dot length. So barricades dot length is going to return the length of my barricades array. So if that's 0, then it will not go inside the if statement. If it's not 0, any other number, then it will go inside the if statement. So then I can say for let b of let b of barricades. Now I want to go through each element of my barricade array, and what are we going to do? I'm going to say b dot set z to b dot get z plus plus z speed. So we created a z speed value, and then what are we going to do? We are going to say check if, actually let's just run this much. So first of all, move obstacles we are going to call inside our game loop. Okay, move obstacles. This is going to be called again and again, so because our obstacles needs to keep moving. Now generate obstacles, we have created the function, but when do we generate these obstacles, right? So what I'm going to do is I'm going to create an obstacle count. Okay, so we don't want the obstacles to be generated again and again and again and again. We want them to be generated after, let's say, each 5 seconds or 4 seconds, something like that. Okay, now what I'm going to do is I am going to so I'm going to show you something else. So what let me just come back here. This was the thing. Okay, so see, I am generating obstacles at a Z position of -40. Okay, and then I will have to turn on the camera for the very last time because this is the last part. Cool. So now see, if the Z is -40 and then we are moving the obstacle in the direction of the player. So what I can say is when Z reach for any obstacle when it reaches -20, okay, then basically this area where the obstacle was created is empty space now. I can create another object. Okay, basically I'm just doing this randomly. There are lots of other ways in which you can generate obstacles. So right now I'm just doing it with the logic that create an obstacle. When these obstacles move to a Z position of 20, then create new set of obstacles here and then move them again. And when they reach to a Z position of -20, then create new obstacles here again. Now, how do I check this -20 thing? I have an easier way. So I created a Z speed value. Okay, and that is 0.2. So see, my obstacles are going to be created at Z -40, and then it will move 20 meters ahead. It will move 20 meters ahead, but it's moving 0.2 units one at a time. So how many times will my game loop has to run to move my obstacles 20 meters ahead? So that's 20 meters divided by number of 0.2 meters in one step. So number of step is 100. After 100 steps, after 100 times my game loop has run, my obstacles have moved 20 meters ahead of the position in which they were created, right? So all I'm going to do is I'm going to keep a count of this number of steps my obstacles have moved. So what I will do is I'm going to create a variable OBS count, okay, and set it to 0. So here I'm going to say if OBS count is 0, if OBS count is equal to 0, then what are we going to do? Then we are going to say call the generate OBS function, and every time my game loop runs, I'm going to increase the value of OBS count. And also if OBS count becomes 100, then set it back to 0. Yeah, because we want to count it again from 0. Then OBS count is equal to 0. Okay, and this should work. Let's hope it works. Yep, it's working. See, so I am getting obstacles See, obstacles are being created randomly. Now what I can do is I can slow down the Z speed and increase the number of counts. And let's run this now. I have slowed down the speed in which everything is moving. So now you can see that my obstacles, they will be created randomly when in any order on the left, right, and center. Oops. Okay, so we have generated obstacles, we have moved the obstacles towards us, and we have moved the grounds. One thing is, so as we keep on generating more and more obstacles, our computer's memory is going to be full. Yeah, we don't want that. We don't want our computer to slow down. So what we should do is, we know that once an obstacle has moved behind us, that obstacle has no use of us. So we can delete that obstacle. So we go to this move obstacle function, and after moving every obstacle, we are going to check if their z position, if b dot get z is greater than, let's say, 20. So my player is at 0. 20 meters behind player is enough distance for the obstacle to not be visible to us, to not be of any use to us. Then we delete the this thing. So now we first of all find out b dot get. So first of all, we find the index of this b element. So barricades dot index of and b. So that is going to be an k. I'm just creating another variable. So k is equal to barricades index of b, and then what? And then we remove the k element from kth element from the array. So barricades dot splice. This is the function. This is how you can remove an element from an array using a splice. So splice function can be used to add and remove elements from an array. Right now I just want to remove an element from which index I'm referring to. So kth index, and how many elements do I want to remove? So k comma 1. Okay, and what do we need to do? We can now ask hatch to destroy object that was b. Okay, and now let's see if we have obstacles behind, if there are obstacles. So actually what we can do is, let's just to check, let's say -20. So obstacles are going to move from -40 to -20 and disappear. Okay, let's run this. It should be working fine. Yeah, see, every set of obstacle that reaches -20 as that position will disappear. So they are getting destroyed, completely destroyed from the scene, from our memory, everywhere. All right, cool. So now let's set it back to 20 and run the script. And yes, so we have done a lot of things here. I hope yeah. So what? Yeah. So we have everything here. We have our player moving up the hill. We what's remaining is creating coins, adding score, and then killing the player when it collides with the top of this barricade thing, making the player roll. So player and animation for this player character, that's left, and score and coins and game over logic. So let's do that in the next part. What I'm going to do is, I'm going to publish this project. So Subway Surfer part 1. So give a description. First part of the Subway Surfer game for Camp K12 TV, episode 60. Cool. And let me publish this. So now I can share this link with all of you guys. You can test the code. You can run the code of this by yourself. So I have this code. I'm going to copy this, and then I can just I can just switch my tab, and I have sent you guys the link of this. Okay, so cool. Let me just turn the camera on for 1 minute. We are done with the stream now. We are done with today's episode. Okay, so we are done with today's episode. We have completed everything. Let me just talk to you guys for a second. So this was Hatch Adults. Yeah, you guys can you guys have the code, the project, the blocks based project of this is also in the description. I can do a separate episode for that if you guys want. And yeah, other than that, so now we are going to be adding tutorials. So one thing that has been missing from Hatch websites has been tutorials for our workspace, for both of our workspace, for adults and kids. So from next week onwards, we are going to be on the Hatch YouTube channel. This is the Camp K12's YouTube channel. You guys can check for Hatch YouTube channel as well, HatchXR. We are going to be doing streams on how to create projects that you guys can you guys ask for, and we are also going to be adding tutorial videos there, and we are going to have a Discord channel as well. Let me so we have a Hatch's Discord channel. I'm going to add the link of the Discord channel in this YouTube video's description after the stream ends, where you guys can post bugs or any issues that you come across while using the Hatch platform, where you guys can just ask for suggest what projects, suggest features, or just discuss with other people who are using the Hatch workspace, and just discuss ideas, projects, and discuss suggest us bugs, suggest us features, show us bugs, suggest features, and everything. Okay, so we are done with today, and let's see you guys in the second part. I'm guessing that will be 2 weeks after today. Next week, I'm guessing Harika ma'am or they will be doing something, and a week after that, I will come back for a part 2 of this. Okay, and I think I'll be doing the part 2 of this on the Hatch's YouTube channel, so you guys stay updated on that channel, and I'll post a video of a part 2 of this directly there, or we can do a live stream there as well. Cool. Chalo, see you guys. I am going to end the stream, so end the stream here. Yeah, I'm going to add the Discord link of Hatch in this video's description. Okay, chalo, bye bye. Thank you for staying, you guys. This was good. Thank you. Bye.